Here's a clock I made as a demonstration for doing a custom gear train assignment. And so this clock has a minute hand and hour hands. So if I rotate my minute hand here, it'll go around. And so I've got a 12:1 gear ratio here so that the minute hand has to go around 12 times before the hour hand goes around once. So let me get all the way back around. And so this uses two simple gear trains compounded together, one with a gear ratio of 3, the other with a gear ratio of 4. And so looking at these parts here, you won't really need some of these, but they do help, especially maybe this part, which is this high strength shaft adapter. These things you can find on the VEX website, but you don't necessarily need to have them. You could leave them off. And so here is a 36 tooth gear that I've started with. To build this, I started by placing that one. And then behind it, I placed this 12 tooth gear. And so for that, you can drag it in and just pull it back so that it's a little bit behind the other one. Then on top of that is a 48 tooth gear. And so for this one, I brought it in and then moved it back and used the gear formula to move it up, and so that gear formula would be for this combination, so it would be 12 plus 48 divided by 48. I think that goes in the Y direction. That's where you would put that in. And then I brought in this next one. That's a 12 tooth gear, and also in the Y direction just moved it directly up using the same gear formula as before. That's 12 plus 48 divided by 48. And then you need to bring in another 48 gear here and another 12 here. To do that, I used the gear formula as before to first bring this one in and then move it up to here. And so that was the same gear formula as before, the 48 plus 12 divided by 48. And I moved it to here. Then I moved it to right here using 12. This I would be referring to that one plus 48 divided by 48, and so that was in the X direction. So you use the same thing in the Y direction and the X direction to place this gear. And then here you just do it in the X direction for this one, and so that would be 36 plus 12 divided by 48. After all the gears are in place, I created two axes through 2 points here and here, following the procedure as before, where you create sketches at the end of each one and then set the point on each side, and then go to construct axis through 2 points, select both points and set them there. And using those 2 points, you can then select some of these parts here that you want to rotate. So you could click on the window here in your browser. That's the shaft, whichever one you use. It doesn't have to be the 2-inch, but then these two, and so you can hold the control key to get both of them at once. And if you press M, you'll be able to move them and switch to rotate, and then select this as your axis to be able to rotate those into place. So you get a little handle here. It allows you to kind of move them back and forth. Cancel that. At this point, everything's sort of static because I've put in all the joints now, so it's not going to move around for me anymore. You want to kind of get everything positioned before you start putting the joints on, because since these Revolute joints are as-built joints that are jointed to the top level component so that essentially they just stay in place as they spin. That also means that once those joints are in there, it won't be able to free move. So you've got to set the gears in their relative place, the gear sense formula first, create the axis through 2 points, then rotate them into place. And once all the gears are in place, then you should bring in some axles like this. And so if you look, this axle, right, doesn't touch the side, so I could turn that off if I wanted to. Or if you look, it's actually got a round hole there for it to spin, because this back area controls the minute hand like this, and this front area controls the hour hand, and they need to be able to spin independently of each other. And so these two parts aren't actually connected, at least directly. Instead, you can think about the start here. This is a capped shaft that I have connected in at the end there, but you could use a regular one if you wanted to. And so I start by doing all the revolute joints and also getting the shaft in. You can do the rigid joints as well to each shaft, and then a revolute joint on each of the shafts, not each of the gears. In the case where you have two revolute joints on a single axle, for example, this gear and this gear, or rather two gears on a single axle, you only need one revolute joint for that. And so you'll set up the rigid and revolute joints after all the pieces are in, and then you'll do the motion links. And so you would motion link, this is a 12 here and a 48 there, and so that's a 4-to-1 gear ratio. And so you'll want to divide the angle it spins at of the larger one by 4 here. And then if this one's rigidly attached to the same axle as the other one, then it will spin when the other one spins. And this one then, over here, has a gear ratio again of 48/12, or 4. And so its angle also needs to be divided by 4. And then this one, again, is actually 1/4. And so instead, there's different ways. You could multiply by 3 or by 4, or divide, depending on which one you're referring to. But either multiplied or divided to get the motion linking correctly. And then these two are also motion linked at the end, with this being a 36 tooth gear, this being a 12, so that's 36/12, which has a gear ratio of 3, right? And so here and here is really the gear ratio for this front set of gears, are these two gears, the 12 and the 36. These two gears over here are actually what you call idler gears, and that this 48 is really meant just to create space, so I could get this one beyond, and this one as well itself needs to have the axle clear to go through. And so this one creates that space, and then this one is needed to reverse the direction. I could have just put it here, which actually I tried it first before I realized that then my hour and minute hands were spinning different directions, and so I needed to also have this one, this gear as well added, so that they would spin the same direction. Now, also it's important to note that this gear here, it's not rigidly joined to its axle. I think I kind of talked about that earlier, right? Because they need to free spin or spin independently of each other. And so you can think about this as being the first gear that starts to rotate, and then it transfers up to this 48 that gives you a gear ratio of 4, and then we compound it here. And even though I got a 48 here, it actually doesn't matter until we get to the last one in this part of the gear train. And so we have the 1/36, but you'll do each one in turn to get the whole thing finished. And that's how it's set up. Here's the multi-view drawing to give you another angle of some of these and what it would look like at the end. And then that's the assembly drawing with things sort of pulled apart. Now all these parts are available on the VEX website. If you wanted to add them, other than the hour and minute hands, these I modeled myself. But really the only pieces you need for this in terms of the custom gear train assignment is the gears and the axles they go through, but you do not need, for example, this piece. You could probably leave off if you need to, and you certainly don't need to make hands, although that would help your grade probably a little bit. And then you also don't necessarily need this piece or even the other piece that's behind it, which was, I think, this one. No, never mind. That's its own piece, but it comes inside of the gear already. And so you can find this as well. It's a shaft insert, a metal shaft insert. You can get it off the VEX website if you want. It'll probably add a little points to your grade if there's some other problems, but it's not necessary and you won't lose points for not having it. And so that's sort of a review, a quick look at the clock I made as an example for the custom gear train assignment.